Today we are going to start our second course, Calculus First. In this course there are total 4 chapters. First, set of real numbers. Then number 2, sequence. Number 3, limit. And number 4, continuity. Okay. Here in this chapter we are going to study some properties of real number. Already in the previous course, that is algebra, we have studied some properties of integers, that is divisibility of integers, then prime numbers, division algorithm, Euclidean algorithm, GCD, then congruence relation. Okay, so same, there are some properties of real numbers that we are going to study in this chapter. That is, for example, absolute values. Here we are going to study. Then supremum, infimum of function we are going to study here in a real number chapter. Sequences, again all of you know that we can count sequence is a function from set of natural number to a real number. Then limit of sequence, convergent of sequence, divergent of sequence, monotone of sequence, increasing sequence, decreasing sequence. These topics we are going to study in the chapter of sequences. Again, limit of function. Okay, so all of you know that what is meant by function, and the limit of function and some properties of function we are going to study in the chapter limit. Here we show that the given function f of x has limit L by using the epsilon delta definition. In the last chapter we are going to study the topic continuity. Okay, so when we said a given function f is continuous, or when we said a given function f is not continuous at a point. So today we are going to start the first chapter, real numbers. Real number. All of you know that the standard number system, the set of natural numbers, integers, rational, irrational, and then set of real numbers. That is, if we take the union of rational and irrational, then it forms a set of real numbers. And also, that is, suppose this is a set of natural numbers n, then this is the set of integers z, then this is the set of rational number q, that is n is a subset of z, z is also subset of q, then irrational numbers. And if we take the union of rational and irrational number, then it forms a set of real number. And we denote the set of real number by using this notation. Okay, this is the notation for set of real number. So set of real number is nothing but the union of rational and irrational number. If we take the union of these two sets, it forms a set of real number. And geometrically you can represent this line represents the set of real number. Here is the 0, 1, minus 1, 2, minus 2. In integers there is some gap. Okay, 0 to 1. If there is a gap, then we can call it the integer number. Okay, but if we fill up this gap by using the rational and irrational number, it forms a complete line, and it is called a real number system. Okay, so now there are some properties of real number. First, algebraic properties. Algebraic properties, that is a plus b is same as b plus a. If you take any two real number and if you take the addition of a plus b, which is same as b plus a, again there exists a number 0 such that a plus 0 is equal to a. Then next, it is covered associative also, a plus b plus c is same as a plus b plus c. Okay, associative. Also you can find an inverse. If a belongs to a plus minus a is equal to 0, that is, what is the inverse of 2 under addition? Minus 2. There exists minuses such that a plus minus a equal to 0. Again, a dot b, a into b, which is same as b into a into b same as b into a. Then a into b into c is same as a into b into c. This is called associative property. Again, there exists a number a into 1 such that a, if you multiply any real number by 1, output again 1. Then if a is not equal to 0, be any real number such that then the what is the inverse of a is 1 by a. Inverse of a is what? 1 by a. That is, what is the inverse of 2? It is 1 by 2 under multiplication, because if we multiply these two numbers, output is what? 1. So 1 is the identity under multiplication and 0 is the identity under addition. So now next there are some order properties also. Order properties. Okay, so few important order properties I am writing here. If a less than b, then a plus c is less than b plus c. Okay, that is, if we add any number on LHS and RHS, sign will not change. Okay. Then number second, if a less than b, then a minus c is less than b minus c. Again the same thing. Sign does not change here. In third case, if a less than b, then AC less than BC if C is greater than 0. If C is positive number, then again if it is less than, the sign again does not change, sign is same. But if number 4, if A is less than B, then AC is greater than BC if C is less than 0. Means what? If you multiply by negative sign with negative number, then this sign will change. If it is less than, then it is converted to greater than, or if it is greater than, it is converted to less than. Then the next number 5, if A less than B, then 1 upon A is greater than 1 upon B. So to remember these properties, we require these properties to solve an example containing inequality. For example, solve A is equal to x belongs to R such that twice x plus 3 less than or equal to 6. So we want to determine all values of x which satisfy this inequality, twice x plus 3 less than or equal to 6. Now to solve this inequality, that is to determine all values of x, here we are going to apply some algebraic and order properties. So here twice x plus 3 less than or equal to 6. So subtract 3 from both sides. Now if you subtract 3 from both sides, sign does not change. If it is less than or equal to, it remains same. So twice x plus 3 minus 3 less than or equal to 6 minus 3. So what this implies, twice x is less than or equal to 3. So again, since we are multiplying by 1 by 2 on both sides, and 1 by 2 is positive number. So if you multiply 1 by 2 on both sides, again sign does not change. Why? Because 1 by 2 is positive number. So what happened here, this 2 will get cancelled here and x is less than or equal to 3 by 2. So what is the answer here? X is equal to A is equal to X belongs to R such that X is less than or equal to 3 by 2, or you can write this is minus infinity to 3 by 2. So hope you understand what is the solution of this equation, this inequality. Now next, second example. Consider set A is equal to X belongs to R such that X square plus X is greater than 2. X square plus X is greater than 2. Now again, we want to determine all values of X which satisfy this inequality. So here X square given X square plus X is greater than 2. Now subtract 2 from both sides. Now what happens when you subtract 2 from both sides? Sign does not change. When sign changes, if you multiply by negative number, then sign changes. Otherwise, in many cases, sign remains same. So here, X square plus X minus 2 is greater than 0. Now if you observe, this is a quadratic equation, and here we want to determine two numbers whose product is minus 2, addition is 1. Such a number are X plus 2 and X minus 1 is greater than 0. Now when the product of two numbers are greater than 0, there are two cases. Case number first, if both numbers are positive, that is X plus 2 is greater than 0 and X plus 1 is greater than 0, or what is case number 2? Case number 2 is what? Both numbers are negative. If these both numbers are negative, then again their product is what? Positive. So what this implies? X plus 2 is less than 0 and X minus 1 is less than 0. So what happened here? Now X plus 2 is greater than 2, implies X is greater than minus 2, and X is greater than 1. Here, or X is less than minus 2 and X is less than 1. So if you observe, if X is greater than minus 2, if X is from these two, we can find an intersection of X. That is, we want to from this two equation, two inequality, we can write if X is greater than 1, then obviously X is greater than minus 2. So what is the solution of this? Here X is greater than 1. So if you don't understand, I am writing here, suppose here minus 2, minus 1, 0, 1, 2. Okay, X is greater than 1 means what? This side, and X is greater than minus 2 means what? This side. So if you observe that, what is that intersecting point? All the points which are greater than 1. Okay, so if you will take X is greater than 1, then obviously it is also greater than minus 2. So the X satisfying X which is greater than 1 will that X satisfy both the condition. So here again from these two, you can observe that if X is less than minus 2, then obviously X is less than 1. Okay, so if you draw geometrically, here you can observe that here minus 2, here is 1. So if X is less than 1, minus 2, then obviously X is less than 1. So what is the intersecting point? So X is less than minus 2. So what is the solution of this two inequality? You can write X is less than minus 2. So what is the solution? X is greater than 1 or X is less than minus 2. Or it means what? Union. Or we write or is for union. That is, this is the solution. Means what? 1 to infinity union minus infinity to minus 2. So this is the solution. X less than minus 2 means what? Minus infinity to minus 2. And X greater than 1 means what? 1 to infinity. Since it is a or, we can write here union. Here and means what? Intersection. All X satisfying X greater than minus 2, X greater than 1. असे कोणते X येतं की हे दोन्ही कंडिशन सॅटिस्फाय करतील? X greater than or equal to 1. इथे पण बघा तुम्ही अँड आहे. सो मग आपलं इंटरसेक्शन घ्यायचं. मग असे कोणते X येतं की जेणेकरून X less than minus 2 असेल, X less than 1 असेल, तर X less than minus 2. So hope you understand. Now next. solve twice x plus 1 divided by x plus 2 which is less than 1. Solve this inequality. Now here we want to solve this inequality. We cannot multiply here x plus 2 directly. When we multiply, when this sign remains same, if our x plus 2 is positive. Otherwise this sign changes. If x plus 2 is negative, then this less than or equal to converted to greater than or equal to. Since we want this number should be less than or equal to 1, so we assume here x plus 2 is greater than 1. So we assume x plus 2 is greater than 0. If x plus 2 is greater than 0, then what happens? If we multiply by positive number on both sides, our sign remains same. That is, this implies twice x plus 1 is less than x plus 2. Hope तुम्हाला हे समजलं असेल की मी x plus 2 का greater than 0 घेतला. जर नाही नसता घेतला तर हे साइन चेंज झालं असतं. म्हणून आपण x plus 2 आता पॉझिटिव्ह घेतलाय. जेणेकरून आपल्याला काय मिळालं? आता x plus 2 ने मल्टिप्लाय केल्यामुळे हा x plus 2 कॅन्सल झालाय. या साइडला x plus 2 मिळाला आपल्याला. नाउ सिन्स आपण जर सबट्रॅक्शन जर घेतलं तर आपलं साइन चेंज होत नाहीये, त्यामुळे मी हा x plus 2 या साइडला घेतो. twice x minus x is less than या 1 ला तिकडे घ्या. 2 minus 1 मला काय मिळणार आहे? x is less than 1. आता बघा x plus 2 greater than 0 implies x is greater than minus 2. So आपला आन्सर काय मिळाले बघा? x is greater than minus 2 and x is less than 1. So what is the answer? Answer is what? X is minus 2 less than x less than 1. Or if you like to write this into interval notation, it is not minus 2 to 1. Do remember what is an interval notation. This is also important. What is AB? This is called an open interval. Open interval means what? A less than x less than b. This is the meaning of open interval. Now what is closed open interval? Okay. So this implies A less than or equal to x less than b. Number 3, A open closed interval. So A less than x less than or equal to b. And number 4, closed interval AB. This implies A less than or equal to x less than or equal to b. म्हणजे ज्यावेळेस आपण क्लोज इंटरवल घेतो म्हणजे त्या इंटरवल मध्ये एंड पॉइंट सुद्धा आपण इन्क्लूड केलेले आहेत. ज्यावेळेस आपण ओपन इंटरवल घेतो त्यावेळेस तो पॉइंट आपण एक्सक्लूड केलेला आहे. जसं इथे बघा A आणि B आपण एंड पॉइंट इन्क्लूड नाही केलेले. इथे मात्र आपण एक एंड पॉइंट इन्क्लूड केला A, B मात्र इन्क्लूड नाही केलेला. इथे आपण B इन्क्लूड केला पण A इन्क्लूड नाही केलेला. So it is A less than x less than or equal to b. So hope you understand. So what is given here? X greater than minus 2 and less than 1. So this is an open interval minus 2 to 1. So hope you understand.